Okay, I think we're recording. So, problem number 1. We were dealing with writing an equation to show that the radius is changing when air is blown into a spherical bubble at a rate of 10 cubic centimeters per second. Find the rate that the radius is changing. First thing, what did we say was the formula that we're going to use that is always true in this problem? Sanjana. V equals 4 over 3 pi r cubed. No, that's not a formula you're going to have memorized. Basically, the ones that are given on the front. Well, no, I can't say that. The bottom 2 given on the front, I will give you on tests and quizzes. Cylinder, we should probably kind of know that one. So the volume equals 4/3 pi r cubed. And there's a rate that we were given, that 10 centimeters cubed per second. And we decided yesterday was that dr dt, the rate of change of the radius, or dv dt, the rate of change of the volume. Done. And Manoj, how do you know? This is what you said yesterday. Use the units to help you figure those things out. We are told that dv dt equals 10 cubic centimeters per second. We are looking for the rate that the radius is changing when the radius is 1 centimeter. We're looking to try to find dr dt. And we want to do this when the radius is 1 centimeter. This is nothing new. We took care of all this stuff yesterday. Do you see where I picked out all of this information from? Do you see how I got what I have on the board? Are there any questions so far? We're going to go and do our derivatives. That's our third step. Remember that everything is a function of t. So what's the derivative of v? dv dt. What's the derivative of a? dA dt. What's the derivative of q? dq dt. We get a d whatever dt at the end of every problem because we're using the chain rule, because everything is a function of time. I guess the only thing that wouldn't apply to is t. We're not going to have those in any problems. Step 3, we are going to find the derivative with respect to time of both sides. I think we did this part yesterday as well. Just to do it again, what is the derivative of v? I just said it like 10 seconds ago. Bless you. Just say it. dv dt. On the other side, there's a lot of constant stuff up front. We have 4/3 pi. Then, we need to do the derivative of r cubed. Well, we'll start normally. The derivative of a cube is 3 times the thing squared, so 3r squared. But by the chain rule, we need to multiply this by the derivative of r, which is what? dr dt. I'm going to clean this up a little bit, and I'm going to say dv dt equals 4 pi r squared dr dt. And I think that that's about where we finished yesterday. I do know that one of these things, that dv dt is always 10, so I'm going to plug that in step 3 as well. I'm going to say 10 equals 4 pi r squared dr dt. Part 4 is when I deal with my specific instant, when I deal with the fact that we want to figure this out in particular when the radius happens to be 1 centimeter. So in part 4, I'm going to take what I just had, and I'm going to plug in 1 for the radius, and I'm going to get 10 equals 4 pi times 1 squared dr dt. Well, I can divide by 4 pi and say 10 over 4 pi equals dr dt. I can simplify that. I'm going to say 5 over 2 pi equals dr dt, and I'm almost there. Because these are word problems, we have to put units in our answers. dv dt was the rate of change of the volume. dr dt is the rate of change of the radius. Well, what's the radius going to be measured in? Centimeters. If the volume is centimeters cubed, the radius is going to be just centimeters. And what's the time measured in? Seconds, because that was the time for our dv dt. Your dr dt is 5 over 2 pi equals, your dr dt is 5 over 2 pi centimeters per second. Questions so far on this? One comment about writing the answer. Please don't give me this for the answer. What's wrong? That's 5 halves pi. You might intend for me to think that the pi is in the bottom. It's not, though. make sure it's clearly written on the bottom, and make sure when you go to manipulate things, the pi is like divided rather than multiplied. I want to skip number 3 for right now, and I want to go on to number 4. And you know what? I would like to see... do you think you could do the setup? I would like to see if you can pick out the formula that we're going to use. Oh, wait, hold on a minute. Yeah, this is what I want to do. I would like to see if you can pick out the formula we're going to use, figure out what rates are given, and write them as dA dt, dB dt, dV dt, whatever. Figure out the rate that we're looking for, and the particular instant we're looking for that rate. See if you can do parts 1 and 2. This volume formula is on the cover, but this is one that I would expect you to know. Volume of a cylinder, volume of any prism, area of the base times how tall it is. Maybe that sounds familiar from freshman year. Nathan, what's one of the rates that we have?
4 feet per minute.
Okay, so what's that going to be? Is that going to be a dH dt, dR dt, dV dt? dR dt. We're told that the radius is decreasing at that rate, so I'm going to say dR dt equals 4 feet per minute. Now, when you just gave that answer, you added another word to that. What other word did you say about the radius? Decreasing. How would I show this? Manoj. We're going to make it negative. If a rate is positive, it means that thing is increasing. If a rate is negative, that means that thing is decreasing. Do we have anything else? Sanjana. Positive or negative?
Positive.
Why? You're right.
Increasing.
Increasing. If something is increasing, we'll make it positive. Negative. Decreasing, we'll make it negative. So this is kind of weird that we were given 2 rates, but let's just kind of keep going from here. What are we looking for? Kwasi, what are we looking for?
We're trying to find the rate of change of the volume.
Oh.
The radius is 2 and the height is 6.
Okay, so in symbols, what am I looking for?
Oh, you're trying to find when dr dt is 2 and when dH.
Yeah. Richie, first of all, what rate am I looking for?
dV dt.
I want to find dV dt. Now, as far as the when part goes, remember that dr dt means not the radius, but the rate of change of the radius. That 2 feet, is that the actual radius, or is that how quickly the radius is changing? That is the radius. So it's not dr dt, it's r equals 2 feet, and h, not dH dt, equals 6 feet. And I always put a box around that to just say, I'm not going to plug these things in until I'm done with everything else, until I've taken care of the calculus. Part 3, I want to do my derivative. So I'm going to do the derivative of v and the derivative of that pi r squared h. The derivative of v is very easy. What's the derivative of v? dv dt. The other side's weird. R squared times h, I have 2 variables there. You know what, though? We can still work with 2 variables here. If you looked at r squared times h, what would you think we'd have to do? Product rule. So watch this. First, r squared times, what's the derivative of the second? dH dt. The derivative of h, dH dt. Plus second, h times, well, what's the derivative of r squared of the first? 2r dr dt. Good. So cleaning this up a little bit, I'm going to get dv dt equals pi times r squared dh dt plus 2hr dr dt. I want to see if you can finish this. You're welcome to use your calculator. You will be allowed a calculator on this entire test. I would finish off part 3 by plugging in those rates that are always the same and not changing. And then part 4 is where you plug in your specific instant, where your radius of 2 feet and your height of 6 feet. So let's see if you can finish this off. Again, feel free to use the calculators. And in fact, you are encouraged to use your calculators. I don't feel like multiplying things out by hand. By the way, before you actually do calculations, will the volume be increasing or decreasing, or can you not tell right now? Yeah, if one thing's increasing, the other thing's decreasing at different, I'm not really sure what's actually going to happen with the volume. When you're done, though, and have your final answer, we should be able to answer that question of, is the volume increasing or decreasing? Go from there. And when you're done, stick units on your answer. Raise your hand if you have an answer. Hannah, what do you have? Good. Negative 88 pi. This is dv dt, so not just feet, but feet cubed, as Hannah said, per minute, because that's how the time was measured. So is the volume of the cylinder increasing or decreasing? Decreasing, because the thing is negative. I need you to ask me some questions. Is this making any more sense than yesterday? That's why the periods are 68 minutes long and not 37 minutes long. Okay. I would like you to do the setup for number 3 and then stop. Because I feel like after you read 3 and start setting it up, you might feel like you're missing some pieces of information. Do as much of the setup for 3 as you can and then stop. How fast does the water level drop when the tank of radius 6 feet is drained at the rate of 3 feet cubed per minute? Here's what I want you to do. I hope I can actually figure this out. I would like you to raise your left hand if you think that 3 feet cubed per minute is dr dt, and raise your right hand if you think it's dv dt. Left if it's dr dt, right if it's dv dt. Why is it dv dt? There is a glaring clue. Aoife, why is it dv dt? Yeah, we're dealing with like the amount of water in there, but there's something that kind of just jumps out at me. Sabrina? The units. Because the units are cubed, that's dv dt. So dv dt is going to equal 3 feet cubed per minute. Good? Harmon, what's wrong? Negative. Good. Does need to be negative 3 feet cubed. Keep asking yourself, is that thing increasing or is it? It might not use the words increasing, decreasing, but you can figure out, is it getting bigger or getting smaller? Okay, what am I looking for? How fast is the water? What's water level? Hannah. dH/dt. When do I want to do this? Casey. Well, here's the deal. How fast does the water level drop when a cylindrical tank of radius 6 feet is drained? Is the radius changing? So when will the radius be 6? The whole time. Okay, so there's a couple issues here. Do we know the specific instant that I want to deal with this problem? We don't. Going back to that radius, though. If the radius isn't changing, isn't that something that I can kind of fill in my information in part 1, because that thing's not changing? If the radius is 6, then actually I could plug that into my formula. I couldn't do this in any other problem because those things were changing. Not true over here. I can plug this in, and I can say v equals pi times 6 squared h, or I can say v equals 36 pi h. That still doesn't solve my problem of I don't know the specific instant to deal with, but it's not going to matter. I want to see if you can go and do the calculus on this thing, find your derivatives, plug things in, and you may not even get to part 4. Not because you can't do it, but because you might be done before you get to part 4. See what you can do. Are you seeing what I meant by you may not even get to part 4, the specific instant? Because I feel like after this line, you plug something in and you're just going to be done. I hope. And when you're done, see if your answer looks like mine. What we just actually figured out is that the height is always changing at that rate of -1/12 pi feet per minute. It's not different based on the instant, basically because of the shape of the thing. Because the thing is a cylinder where the radius is always the same thing, as the volume decreases, the height's decreasing at a constant rate. Can we get -1/12 feet per minute? Quasi.
For pi h, did we use product rule to find the derivative?
Why am I not doing that? That's why. I'm using the constant multiplier rule. 36 pi is just going to stay out front, just the derivative of h then. Okay, there are 2 more area and volume problems that I want to look at with you that are a little bit trickier. We'll probably get one done before lunch. We'll finish the other one after lunch, and then we'll start looking at a second type of related rates problem, probably. Turn the page. There is a reason there's only one problem on this page. Let's see. So, sand falls at the rate of 30 feet cubed per minute on top of a conical pile. The height of the pile is always 3/8 of the base diameter. How fast is the height changing when the pile is 12 feet high? So we have, like sand, falling on, not sure why it was curving like that. We have sand falling and creating a conical pile. Conical, hopefully we realize, means cone. It's creating a pile in the shape of a cone. So I feel like we need a formula. Do you know what the formula is for volume of a cone? You know where you can find it? Do that. This is one that, no, I would give to you. Cylinder, we should know. The rest I'll give you. What is it? 1/3 pi r squared. You want to say anything else? H. 1/3 pi r squared h. What rate do I have? Bree, is that a hand? What rate do we have? Okay, so what's that going to be? dv dt, dr dt, dh dt. dv dt, good. And now, as far as the pile's concerned, is that going to be a positive rate or a negative rate? Yeah, we are building up this pile. Yeah, it's falling off somewhere else, but we're creating this pile. We are increasing its volume, so 30 feet cubed per minute. Leave a space. I'm going to do a little more work in part 1 in a little bit, but I'm going to come down to part 2. You go do part 2. Figure out what rate we're looking for and the specific instant. Don't go on after that. Kaylee, what are we looking for here?
I said DHTT.
Yeah, you're right.
H equals 12.
Good. We want to find dHdt when h equals 12 feet. Okay. Here's the problem. We are given all this information about h. Are we given like how r is changing and a specific radius and those? We're not. There is something we were told, though, that we're going to have to make use of. Manoj, what were we told that we haven't done anything with yet? Okay, the height is always 3/8 of the diameter. I'm going to fill that in part 1. I know that the height is always 3/8 of the diameter. Well, in some ways this is even worse because now I have a new variable here. But diameter, how could we rewrite diameter to make it more useful? Sabrina? 2r. So why don't we say h equals 3/8 times 2r, or really h equals 3/4 r. What I'm allowed to do is I can do some substitution to plug into my original volume formula to get that volume formula in terms of just one variable, in terms of either h or r. I guess my question, though, before I do that is, what do I want? What variable do I want in my problem? Do I want h's in there, or do I want r's in there? We want h's because we have dHdt. So shall we just take this 3/4 r, plug it in for the r? Well, I'll plug it in for the h and go? Yes? No? Bree, why not? Yeah, we want r's. So you got to do like a tiny little bit of algebra, not much algebra. You need to solve that thing for r. Then once you have that, I'd like you to plug that into your original volume formula. We haven't done a lick of calculus yet. That's fine. Solve for r, plug it in, and we'll get a formula that we will then apply our calculus to. I'm just kind of put that whole constant thing as one big thing out front with the pi wrapped in there. Can we get v equals 16 pi over 27 h cubed? Well, I feel like you should probably be able to go from there. I want to find dHdt when the height is 12. Well, this is the function we're working with. Even though it looks messy, it's mostly just a constant. See what you can do. Please feel free to use your calculators to do the calculations and see how far you can get with this one. can sign up and, sorry, everything's kind of a mess over here. Books over there and sign up sheet is on the bulletin board. I would like you to try to give an exact answer here rather than just going to decimals. So let's try to give an answer with pies in it. Bless you. I'm getting 15 over 128 pi feet per minute. Any questions at all on this one? By the way, in the homework tonight, and actually throughout the entire rest of the unit, every homework problem should look pretty similar to one of these examples, so definitely make sure you have this packet of examples with you and kind of match these up to things in the homework. I'm not going to try to give you things that are totally random and weird and stuff, because the AP exam doesn't really do that with these either. They kind of have the same basic ideas, so use this. I would like to see if you can read and set up number 6, but we're not going to get to the solving, nor are we going to get to the random weird trick in number 6 probably until after lunch. Bless you. I hope you got the formula. V equals 1/3 pi r squared h. That's the easy part. And I hope you were able to figure out the rate. What rates, Jess, were we given? Good. Is what? Good? Jess? Okay, hold on a second to that. Let's stick with the dv dt for a moment. Hannah? Make it negative. We'll deal with the rest later. We're going to pause this.